Can you hear me back there? Back, okay?
Yeah.
It's my honor to introduce Rolf Ilsley, founder of Optical Coating Laboratory, Inc., known as OCLI, or OCLI for short, as the 2014 Nathaniel H. Sugerman Awardee. The Nathaniel Sugerman Award has been given for, I think, 22 years, and it is a recognition for significant impact on the industry. I don't have the wording right in front of me, but for significant impact on the industry and the SVC. He's been nominated for his entrepreneurship in leading the creation of the optical vacuum coating industry in the United States. In 1999, OCLI was acquired by JDS Uniphase, now JDSU. Luke Scribinich, General Manager of the Optical Security and Performance Products Division of JDSU, is not able to be here, but has generously agreed to co-sponsor the reception tonight in honor of Rolf's award. I would like to acknowledge these people for assistance in preparing this presentation. In particular, I would like to recognize Beth Strong, who works with the SVC and was very helpful in putting this together. Rolf Ilsley stands apart from other Sugerman Award awardees whose contributions to the vacuum coating industry and the SVC were much more explicit. Rolf's many contributions have been perhaps less apparent, and with many of them happening before many people in this room were born. To set the stage for this introduction, let me propose the following statement. The people in this room, in this hotel, in this city, in this country, and a very large fraction of the people on this planet that we either use products enabled by, or information provided through the use of optical coatings produced by the company Rolf Ilsley created and ran for more than 40 years. This may sound like hyperbole, so let me give you some background in support of this statement. In 1948, Rolf Ilsley started OCLI in Washington, D.C., and in 1951 moved it to a storefront location in Santa Rosa, California. By 1995, the company had $200 million in annual sales with more than 100 coating machines and 1,500 employees in the U.S. and Europe. If you have used U.S. currency, a Chinese 100 yuan note, an Indian 1,000 rupee note, or notes from dozens of other countries, you have used optical variable optical variable thin film pigment that Rolf and his people created and produced. If you made a long distance call that used fiber optics or a communication satellite, a filter or other optical component made by OCLI helped make this possible. If you received a weather forecast, followed the Mercury, Gemini, Apollo, or almost any other space mission in the 20th century, you enjoyed the benefit of OCLI's contributions. There are OCLI coatings on the Voyager 1 and Voyager 2 spacecrafts now exiting the solar system. How about that for product reach? In fact, almost any product where light has been put to work has very likely, at one time or other, seen the benefit of OCLI coatings or coating technology. Examples include Polaroid cameras, Xerox copiers, projection televisions, and even rock concert lighting. Here, Rolf is accepting a 1969 technical Oscar for OCLI anti-reflection coatings used in Hollywood. After serving in the South Pacific as an officer in the U.S. Navy, Rolf founded OCLI. Trained as an agricultural engineer, Rolf saw promise in the technology developed during World War II for the manufacture of magnesium fluoride anti-reflection coatings. Moving to California on a motorcycle, I might add, he began the process of finding the people, technology, products, and capital that eventually resulted in OCLI becoming the largest supplier of optical coatings in the United States, serving markets and products that did not exist just a few years earlier. Did Rolf do all this personally? Of course not. But but he did make it happen, including contributing as an inventor on multiple occasions. For example, here's Rolf's 1964 patent for a double rotary motion, a critical bit of technology for his new company. As recognized in this newspaper article, Rolf is a true entrepreneur with that innate ability to see opportunities where other people see problems, or even where others see nothing at all, and a willingness, time and again, to take large but calculated risks to pursue these opportunities. He surrounded himself with people who were highly skilled, motivated, inventive, and who shared his vision. Here are some of the early optical coating scientists and engineers whose name many of you will recognize. We see in the upper right-hand corner, Alfred Thalen is using an IBM 1600 computer. I programmed one of those to model thin films in Oakley 50 years ago. With these people, and building on what was available from the outside, Rolf's leadership guided the creation of precision evaporative, and later, sputter coating processes in many sizes and configurations to match the needs of the products that they were to make. These products were scaled by the development of large roll coaters and inline coating machines capable of true mass production. Here you see two roll coating machines that can manufacture literally tons of precision multi-layer optical pigment for security applications. This is MAC, to my knowledge, the first inline coating machine capable of multi-layer optical coatings. First producing for the Polaroid instant camera, some of you remember that. MAC ran continuously from 1970 until about 4 weeks ago, making millions of square feet of enhanced first surface mirrors. These were 97% reflectivity mirrors and HEA anti-reflective coated glass. Rolf will tell you in a few minutes a little bit more about some of these machines. Rolf also introduced some management practices that were innovative at the time, including the effective communication process, which is a process allowing employees to write a question anonymously to management, and the question will be answered to all employees in writing. And an ESOP plan where employees could buy subsidized company stock, doing so well before this process, this was a common procedure. Many employees accumulated significant wealth with this plan. During business ups and downs, the company endeavored to apply surplus capacity to training and research and development. It took a major lasting change in the business environment to precipitate a layoff. As a consequence, highly trained, long-time employees were the rule. I had the honor to work directly for Rolf for a number of years and saw firsthand his flexibility toward his employees. When, for personal reasons, I needed to move back to Missouri, that's a state one over from here, from California, Rolf adjusted my responsibilities, allowing me to become an early telecommuter, and which I did for 10 years before I retired. I note that the week that I retired, so I'm going back and forth between Missouri and California, the week that I retired, TWA went out of business. But you can also see we have a little fun along the way. I personally owe Rolf a great deal. In the late 80s and 90s, at any given time, Oakley employed more than 200 degree scientists and engineers. We can count at least 45, several in this room today, who contributed in many ways to the SVC. Oakley, now part of JDSU, has long been an SVC corporate sponsor. Several years ago, Rolf and his wife Helen endowed the Helen and Rolf Mosley Scholarship Fund and the SVC Foundation, and he's already benefited several of these students. So, my point here is that along with his impact on the industry, Rolf has also had a profound impact on the SVC. On a more personal note, I can recall in a staff meeting, Rolf telling us about his advice to his 4 children. And his advice was, first figure out what you like to do, then figure out how to create a life doing it. And he very much embraces that, his own advice. For example, both Rolf and his wife, Helen, love flying. And both are longtime pilots. But when age became a factor in renewing Rolf's pilot license, they bought a fully instrumented motor glider, which does not require the same medical examination. So Rolf, at age 92, and his co-pilot Helen still flying. So the lesson from this is, as is typical for Rolf, a problem becomes an opportunity. Rolf maniacally innovated and prospered for more than half a century, employing thousands of people and generating several $billion in total sales. This places Rolf in that class of entrepreneurs who were successful over the long haul, differing only in scale from people like Steve Jobs and Bill Gates. So, in conclusion, we see that it's entirely appropriate that we honor Rolf tonight. Rolf and Helen, would you come forward and receive the award?
Sugerman Award. Thank you very much for your leadership.
Thank you, thank you. Can you make it down? Can you hear me in the back? Can you hear me in the back?
Yes.
Okay. Whoa, wow. What an introduction. Jim, are you sure you were talking about me? I don't remember doing all those good things, but then maybe the reason I don't remember is because of my age. I know I don't look it because of this full head of beautiful hair, but that belies what is underneath this hair. My memory, after 92 years, is no longer that good. Just ask Jim Caesar and Brian, what's his name? Yeah, Brian Mitchell. I'm just kidding. Joking aside, I am sure they both are conscious of my age, and I think that explains what happened a few months ago. I received phone calls from both Jim and Bryant. We talked about this convention and the Nathaniel Sugerman Award. Now, I don't claim to know what happened next, but I have my suspicions. I think Jim and Brian had a little discussion. Based on their having talked with me, they were trying to decide whether under this head of hair, this old fuddy-duddy is still with it enough to be entrusted with making a speech to this esteemed audience. Obviously, they must have concluded I am, because I am here. Now, if they realize they made a terrible mistake, it's too late, because it would take a long book to get me off the stage. in spite of my attempts at humor, please let me assure you that I feel very honored to be receiving this prestigious award. I am in good company. I personally knew Hugh Smith, the 1993 recipient, Richard Denton, the 1995 recipient, and his son Peter, the recipient in the year 2000. Is Peter here now? I think his company is exhibiting here this year. By the way, I apologize. At my age, my eyes give me some difficulty reading, so I will stumble some in reading. Bearing in mind your likely interests, I have decided, is this being used or not?
Yeah.
Okay. Bearing in mind your interests, I decided to talk today about 3 coating machine designs that were key to the success of Hockley. The first one was the double rotary machine that Jim has already shown in the photograph. At the time of founding Hockley, most of the industry used glass or metal bell jars about 18 inches diameter, enclosing a stationary domed rack centered over the coating sources. Looking to improve uniformity, in the mid-1950s we purchased in Europe a machine with a rotating rack and coating sources off to the side. As time went on, we upgraded this design in order to produce multiple layers and good thickness monitoring. As our first volume market was for a 15-layer coating to reflect the ultraviolet sunlight from the glass covers cemented to solar cells, producing electric current on satellites in space. As the volume for these cell covers grew, we started to look for ways to reduce the cost without reducing the quality. This led to my invention of the double rotary motion machine. The basic idea was, why not offset the source a bit further and add another rack? For that matter, why not offset a little more and coat 4 racks simultaneously? May we have the first slide of that? It is the double, okay. We had it a while back. It was actually the patent. Then came the big idea, why not also rotate all the racks around the center of the chamber? Once we did this, we found there were 2 major benefits. The double rotation led to the greatest degree of uniformity we had seen up to that point, and the large load size reduced costs dramatically. This became the subject of my first patent. Of course, today, this chamber layout is very common in the semiconductor industry. The next piece of equipment where I made a major management decision was when, in the late 1960s, we developed a multi-layer automatic coater. Maybe you see that. Oh, did we pass it?
One more.
Okay, keep going. Keep going. There we go. There we are. There we are. Over on the left-hand side. Those are all the diffusion pumps in a line. At that time, for a typical coating run, it took 15 minutes to load the parts and the coating material, pump the rough vacuum, apply the high voltage low discharge, heat the parts, reach a good vacuum, apply the coating layer or layers, cool the parts, bleed in the air, and unload the machine. 45 minutes. Then one day an idea struck me. If we're coating no more than a half dozen layers, how about running all the sources simultaneously and continuously? We should be able to go a tremendous volume at a much, much lower cost. That seemed like a marvelous idea, but there were a couple of critical questions. First, was the market big enough to justify such an expensive machine? As a conscientious businessman, I hired a marketing consultant to study the potential annual market for coatings costing only $1 a square foot. He came back with the answer of $500,000. But we estimated the machine would cost $2 million. Ouch! That obviously was a no-go. Then I happened to ask him, what price did you use? He responded, oh, because the men on the production line would really have to be the ones to deliver. I asked them, and they said $2 a square foot. With that, I thanked him and paid him off. I wasn't going to send him out with instructions to do it again at my price of $1, because he might come back with a number not much higher. Therefore, I decided, go ahead, just based on my gut feeling. Next, there was the enormous task of designing and constructing the machine. The first problem was the design of the evaporation sources. We decided to use rotating electron beam evaporation. The filaments we normally use typically failed after only a few hours, yet we planned to run the machine around the clock. It took months to develop the long life sources we finally used. Then came the problem of reloading the coating material without breaking vacuum. To do this, we purchased a vacuum furnace and produced solid billets of the various coating materials, which we then entered through a vacuum lock and up into the coating source without interrupting the coating process. Finally, we had to develop a deposition rate monitor to monitor the rate at which the film grew, because it had to be at the correct thickness at the precise time it exited one chamber and entered the next. Finally, after 2 years of determined effort, the machine was ready for the first test run of a multi-layer anti-reflection coating. We each held our breath. The machine ran for only a few minutes, but before something went wrong. But in that short time, it produced over 100 square feet of good coatings. Really? We all were very excited because we knew we had created something. Just how successful the Mac would be, we had no way of knowing at the time. When I last visited the plant 2 years ago, the Mac had been through various minor upgrades, but the previous year it brought in over $10 million of revenue on a machine that cost $2 million. It is almost unheard of for a piece of production equipment to have a useful life of over 40 years. Next slide, please.
Go backwards. Backwards.
Okay.
Keep going backwards.
The final piece of equipment I want to talk about is the high-rate roll coater. In the mid-1970s, yeah, there we are, on the right-hand side. In the mid-1970s, I attended a conference in New York City to learn about coating on rolls of plastic film. Because it was 5 o'clock in the morning, California time, when the meeting started, my eyelids soon began to droop. Then the speaker mumbled something about coating costs of around a penny a square foot. A penny a square foot? That did it. I was immediately wide awake. I wanted to know more, a lot more. How sophisticated were these coatings? Not very. These people measured the thickness of a metal film by holding it up to the light and trying to see through it. Durability and pinholes were not a concern. No wonder the costs were so low. But now came the big question. Suppose there were a market for much more sophisticated coatings on plastic film. would the existing roll coating people be able to upgrade their skills, or would we be able to downgrade our equipment first? I felt we probably would be the winners of such a race. Once I returned to Santa Rosa, I called a meeting of all of our staff. The consensus was this would be a good business for Ockley. Therefore, the first step was to determine what kind of products might emerge from the coating process we might develop. Several things seemed feasible, so we decided to proceed with designing a machine which we knew would be quite unique. What we came up with was a far cry from anything anyone else had ever built. However, we also knew it would be very expensive, so in 1980, we raised $15 million by sale of stock. With all the preliminaries out of the way, we began construction of the machine. Design called for 30-inch wide rolls of plastic that were kilometers in length to be loaded into the number 1 chamber and pumped down. Then the plastic web would pass over the first coating source, followed by passing over the second coating source, and then into the number 2 chamber. Depending upon the design, several alternating layers could be deposited by passing the web back and forth. The first major market we discussed was window film to reduce solar heating. But then our big opportunity arrived. There was worldwide interest in the use of color-shifting thin films for anti-counterfeiting. This was based on the shift in color when a multi-layered interference filter is viewed at various angles. The problem was how to hot stamp the coating in some form on the currency. Then one of our engineers at Ockley came up with a brilliant idea. Deposit the multi-layer coating on long rolls of plastic. Strip the coating off, grind it into small flakes, and put it in the printing ink. Eureka! It worked. Ockley built a special building with high security, housing several $20 billion coating machines for producing this pigment. Over a period of years, this technique gained worldwide acceptance, as Jim mentioned, over 100 countries. Today, the total annual sales volume is in excess of $200 billion for that pigment. On U.S. currency, this color shift can be seen as the number on the lower right side, on the lower right of the back side of all currency except the $1 and $5 bills. On the new $100 bill, it appears an angle as a greenish Liberty Bell that disappears within the gold-colored ink when viewed straight on. The adjacent numeral 100 also shows a color shift in a very pronounced fashion. In order to make sure you would be able to understand what I was talking about, I proposed to Helen to pass out to each one of you a $100 bill. But she vetoed the idea because we didn't have enough room for them in our suitcase. With that little bit of nonsense, I close my description of 3 key pieces of productive equipment which I sponsored while at Ockley. In closing, I have one request. Any of you who think Jim and Brian made the right decision by asking me to speak here today, please show them by putting your hands together and clapping.